Welcome back to Made Up of Wires. We're decompiling Castlevania Symphony of the Night. I wanted to do a quick overview of what decompiling is before we get started today, just as a way to introduce new people to the idea and give a quick overview of what we're doing and how it's done. So when the developers are making a game like Castlevania Symphony of the Night, they have some source code. If they were targeting the PlayStation, they're going to compile that source code with GCC. Otherwise, if they were targeting the PSP, they're going to use MetroWorks. Typically, that was the supported development environments for those systems. Those then compile to a machine code, which is then put on a disk. And that's the game that we play. And that's what we have when we decompile. So when we decompile, we go in the opposite direction. We have the game disks. We don't have anything else. From those game disks, we can pull the code that was shipped on the disk, the machine code that was compiled. Then using tools and just our own problem solving, what we're trying to do is get back to that source code. And when we get back to the source code, we want that to be able to go in reverse and be able to do the same thing that the original did, be able to compile that and get exactly what was shipped on the disk back. So that's what we're doing on Symphony of the Night. And we've made quite a bit of progress. Give me 1 second. If you're not familiar with the project, you can go to soten.z.dev to see that progress. There's several of the overlays that we've worked on to this point. And we've been working on the sword familiar over the past couple weeks. There's 4 functions remaining on the sword familiar. And these are all have their own idiosyncrasies that make them a little bit difficult to finish off. So I'm going to go through those and just review what there is and what the problems remaining are. And then from there, either work on, there's one that there definitely is just manual labor that needs to go into. And then there are 3 others that have little tricks that haven't been figured out yet. So let me get my list. I have the permuter going for one of those. The decomp permuter is a tool that's used to kind of brute force small changes in files to see if common differences that should compile to the same thing might exist. Let me open my to-do list. So we have these 4 remaining functions. We'll just go through those one by one. The first one isn't, this is the one that just needs some manual labor. It shouldn't take much additional work. The hard part about this function was primarily in the macros that it uses. So this function uses a lot of inline assembly that was provided by the PlayStation SDK, but the SDK provides macros for accessing that assembly, but it's a little more difficult. It's not as simple as function calls like we normally would see. So there's a bunch of stuff in here that either it's, in this case, it's references to memory addresses, which should be fields of structs, and some other things. So this is a good candidate to work on today because there's still some reasonably straightforward work that can be done there without too much thinking. Let me see this one. So this one is nearly done. 99.71 on a lot of functions, that would be a match. But in this function, not quite. And there's one issue, and we'll look at the assembly between the target and what we have. And it's down here on line 146. Something that seems like it's relatively mundane. This do while loop is in here to force this close of a match. There is this assignment to the argument 0 register. In the original, this is happening before which assignment? It's happening before this assignment on line 143, and the compiler is free to do that in whatever order it wants, as long as it's not affecting anything. And we see something that looks more typical, more like what you'd expect, where the 0 argument is being assigned right around the same place that the function is being called. But in the target version, that argument 0 register is being set much earlier. And so once that instruction gets resolved, then this function would match. And so this is something that I normally would probably throw in the permuter, or I might go to Discord and say, hey, can anybody help identify what's going on with this last function? I will check one thing while I'm here. I noticed that in some of these instances I had the wrong signature for this function. So that's number 2. That one's really close. Number 3. This function, let's see what's going on with this one. This one looks like, I think this might have been the one we were working on yesterday, and I think this just needs some work as well. Nothing terribly complicated. It just needs to be worked on. And then the last one, I was trying to work on this one earlier, and it frustrates me. So this is similar to, in this one, I have several different versions of these, trying different strategies for decompiling. This is the closest for the PlayStation that I have. This one matches with the exception of this section down here at the bottom. And it has to do with how these addresses are being loaded and used. And what's frustrating about this function is that there is a PSP version of this function that is effectively matching. On the PSP, we're always going to have the way that I go about it. We're always going to have more differences on the PSP because symbol names are different, and those are largely ignored. But for the most part, the PSP matches. So I might have to start diving in and assigning some of these names and get a true match on PSP to see if there's something else that was missing. And actually, that might be a good thing to do today. That's kind of how I'm feeling today, is maybe do something that is a little more mundane, but requires a little less thinking as well. Morning, Orcam. Good to have you on. So why don't we go about that? So we're going to look at adding some symbol mappings to the PSP assembly extraction. And when we do that, we should get symbol names that match. And there's two classes of symbols that we need to worry about. There's and those are based on where in memory the functions or global variables are going to live. There's things like destroy entity, which is a part of the game engine itself and lives in a lower region of memory. And then there's things that are part of the familiar overlays, which are at a higher area of memory. Morning, Dig Down Deep. Good to have you. Evening, Dig Down Deep. So I'm going to get started on that and just start mapping some of these symbols. Some of them I think are good to have regardless of this overlay or not, and will be helpful in other areas. So I'm going to open, we have a symbol table already for the PSP. And I just want the root symbol table. And things like destroy entity, I really would have expected would be in here already, but they're not. And the way this table works is you provide a symbol name, which could be a variable or function, anything like that, anything with global scope, and then you give it the address in memory where you expect it to be. There are things like GAPI. Oops, I want to search for that, not type it. Where we can name the function and give it a symbol name. It won't, it'll just help us as we're reading. Missing some numbers. Yeah. So I'm just flipping back and forth between here where I see these unnamed symbols, and then on the right where we have names. And so what's funny about this, or maybe funny is not the right word, what we're going to be doing is giving the PSP a bunch of anonymous symbols that were started with the that came from the PlayStation. So they're going to look like memory address symbols. So for example, this 63C, this looks like a offset in memory. It's the PlayStation offset in memory, not the PSP offset in memory. This can be hard to reason about later when trying to debug offset issues or other things like that. I'll start with a couple, and then rerun the extraction and load that assembly. So for this function, function names are different as well. I'm actually going to give this function the same name as the PlayStation version as well. And let's run the extract. It looks like I'm missing this file. Let me regenerate it. So I'm going to be looking in the disks, PSP EU, and I want the TT004 bin. It's been mentioned on the channel before, but there's two versions of each of the binaries that ship. One we believe to be like a development version of the game that is compiled with GCC and looks a lot like the PlayStation version of the game, but it has references to paths on a hard drive, and then the version of the game that shipped. What's interesting about this HD version is that it has shipped with every version of the game since the PSP version, despite, as far as we know, not doing anything. Nice to have a third version of the game available, though. So we have a script that will make some splat config, hopefully. I'd have to use the one that I wrote. There we go. Okay, so this is interesting. I had added this allocate primitives function, but it appears... Oh, I did it incorrectly. That's why. There was a negative offset. So let me run that again. Okay, so now we should have a splat config, and we can split that assembly and then find the PSP function. Unfortunately, this also puts a bunch of C files that will try to be compiled. And so I'll have to clean those up before building again. Oh, where is this function? So this is where this function starts, but it doesn't appear to have been split correctly. Oh no, it has been. Why couldn't I? Oh, function was given a US name. Oh, because I named it that. That's why. Yeah, I just manually delete them. Git status will tell me where they are, what they are. So in the servant TT004 directory, there's this 80.c. And so this will screw up if I try to compile the US version, but it's mostly because there's a bunch of symbols that are not declared that I can't find. Or are not where it expects them to be. Okay, so now I'm going to go down and so we have this first one. This is an issue with how M2C attempts to resolve symbols. So this is kind of an interesting idiom or what heuristic that M2C uses to try to determine if these values that are being loaded into a register are references to a symbol or just numbers. And it seems like it doesn't deal with the negative values. And that might be something to look into. I've kind of done the opposite, looking at the M2C extraction and try to figure out when it's trying to, or when it determines that those are symbols. It does a reasonably good job, but that's nice to then mask out those symbols when trying to find duplicates. So I'm going to go through, and what we want is anything that starts with PSPEU. We want to find those, and those are the ones that I'll need to get the mapping for the PlayStation version. And this is just going to be a rinse and repeat over and over and over, doing kind of the same thing, finding the missing symbols and adding them to this table. Most of the time, this isn't necessary, obviously. I don't do this a lot on the stream. But it can be helpful, and a lot of the time, I'll do something like this, and then find the error that made me go down this path to begin with. So I'm scrolling through on the decomp.me version, trying to see any symbols that I don't have yet. And that relies somewhat on me remembering what I've seen before, which is a process that is full of errors. Most of these are there. I'm going to run an extract again and see what has changed. Oh, this says that we got them all. Okay, so if that's the case, then what we can do is create a new scratch. So I was just looking for anything that starts with D_PSPEU, which all of those unnamed symbols will be, and it didn't find anything. So I'm going to create a new scratch, and pardon the tab mess. Use this same context since it is working, and then create a scratch. And what I'm hoping for here is that most of the symbols, if not all of them, will match. And now I have a better idea of where where there might be problems. So looking at the two, there's actually this version is matching better than my symbolified version. And so I need to figure out why that might be. Let's try that one more time. Definitely not what I expected. Oh, there are, is it possible that there are some PSP things that I don't have? Let's see. Let's see what might be going on. So there may be type issues here. I feel like yesterday there was something like this where, oh, I know what the issues are. Me being forgetful. I need to make sure that the PSP version PSP macro set. There we go. Okay, so now we only have 10, a difference of 10. So that's almost perfect. And I'm hoping that this is really the only one here on line 9. That makes me pretty hopeful. It is possible that there is something else. No, there's not. So this was a match with the exception of the symbols. And now it's kind of proven out that that is the case. This allocate primitives function being the only one that's missing. But that's just because M2C didn't resolve that symbol. We could manually resolve that symbol and start a new scratch, and it would give us a 100% match then. So there are no differences in this version. So when going over then to the PlayStation version, you'd expect that to be relatively close, but it's not. And again, there's something about the structure of this global that GCC is treating differently. And it's unclear to me what that might be. So what you usually expect when accessing fields of a struct through a pointer or through a variable that represents that struct, when you have several instances of fields in the same structure of memory, on GCC you expect some register to load that address, this 63C address, which is happening up here. And then this register has the address in it, and so we just need offsets into that address to get the different field structs. And that's what our compiled version is doing, but in the original that's not what's happening. In the original, it's calculating an offset first, and then shifting based on the index into that other offset. So it's almost as if you have a set of arrays that are all overlapping off by one 32-bit integer in their starting point. And so it can be written that way. It's just a very odd way to do it. The thing that makes this that makes me think it's an array of structs and not something else, like just an array of integers or an array of arrays, is that the priority field in that structure is 16-bit, and I believe there's a draw mode field in there as well. But these other fields are 32-bit, and they're actually not even 32-bit. They're two 16-bit values that are just being referenced as a single 32-bit value. The whole thing and the way that it's written is really unlike anything else that I've seen. So yeah, it's somewhat unfortunate that that this is so close, and we could actually replace the PSP function, and we'd have a matching PSP implementation, but not a PlayStation implementation at this point. That's just kind of the way that it is. So there's something else going on here that I'm not sure about. All right, so those are the 4 remaining functions for the sword familiar. Sorry. I guess let's go and work on 8C8. That is probably where the most progress can be made. I don't think that I pulled this PSP function yet, but let me make sure. It's possibly this one. Yes, that is it. All right, so let me note that. And we'll spend time on the PSP version. Even in the 90s, hint line was, what, $1.99, $2.99 a minute? I doubt that they ever charged 79 cents or 70, 70 cents in the US. They were always much more than that. I don't know if oops, that's not what I wanted. I don't know if I went through and cleaned up these variables yet, so let me do that and get rid of as much as I can. That's still there. This is one of those functions where, oops, can't get rid of that. I have some mental block where I just don't want to think about it, but it needs to be done. I wonder if I can get away with a max here or a ternary. We'll see. It'd be nice to not have that extra variable. I don't think it's the. Yeah, I don't think it's any better or worse. So I'll leave it like that, and then this A1 variable can go away. Oh yeah, now I remember this function. This is where I didn't want to think about how it's incrementing through the list of primitives. Thinking about that a little more, I think what I said yesterday was inaccurate about how the primitive list works, or the primitive buffer. The primitives that you get aren't necessarily contiguous in memory. They are a linked list. So when you call alloc primitives, you get the head of that list back, and they all have next pointers then, where you can walk that list, and they're not necessarily contiguous. Yeah, I mean, so thanks for commenting, Dragon X24, Dragon Times 24, Dragon 24. Yeah, I do hope that it is something that will enable more mods and other things like that, and I think a lot of the people working on the project feel the same way. All right, so I'm gonna just kind of run down top to bottom and see what where there might be differences again. Just reminding myself of what was happening in the project. So there is this move. This is kind of an odd arrangement of instructions. So the way our code is currently being compiled, we're loading this 63F into the A1 register, which is usually the second argument to a function. And then immediately the contents of that register, A1, is getting moved to A0, which is the first argument of a function. And then that function is being called with that value. Why that extra step is being taken isn't clear to me. The way that these A registers are being used is very different. Most of the time, this isn't something that can be resolved very easily. At least not at this area in code. It has something else further down, which is going to change how the registers are allocated, is how that will be resolved. One thing I didn't notice earlier, so all of our local variables seem like they are occupying the correct slots in the stack. However, the stack is 16 bytes larger in the original than ours is. So there is something missing, but nothing that we're pushing on the stack through a local variable. So something else is getting pushed on the stack for another reason. So registers and immediates are not a big deal. I could go through this one as well and make sure all those symbols are mapped, but I'm not going to do that until we know a little more. So here's a branch that is looks possibly different, and it depends if there are missing instructions or not. So we're branching to C18 or VC4. So let's go back up. That's way up at the top. No, sorry, way down at the bottom. And so those are, yeah, this is the end of the function. Same spot. So there's just things that are missing in the middle. Sorry about the audio, Orcam. I dropped the frame rate as suggested yesterday, which I don't know if that would cause any issues. At least not on my side. All right, so our first issue is here, which is where we ended yesterday, or I skipped over this yesterday. So we're walking through a linked list. So we have some primitive structure. A primitive is a quad. It has things like x0, y0. The four corners of what that quad is. Some details about texture coordinates and things like that. And next is going to point to another primitive of the same type. And what this looks like it is doing is going through and finding the last node in this list. And that node is going to, or maybe not the last node, but we're trying to find some node at this offset, whatever this global variable is, has some integer offset, and we're going to that nth or e8th, 5e8th entry. And so this next pointer could be null, it could be something else. So after this loop is done, prim is going to be pointing to this value. Next is going to be pointing to this value. I might rename next last, just to keep that a little more clear. Oh, I have a last already. And that's what we're calling this. So that last pointer is being stored off. And then we're doing this, basically copying everything from prim to next. But we need to keep that last pointer. So this one we call last. And restore that value after it's been overwritten. And that's what's being done. So what seems to be missing is oh, maybe it's as simple as this. Yeah, unfortunately, this is going to cause a bunch of additional loads, because every time we have to get that next pointer. So that's not it. And do I have... some of the offsets are, oh, not that. Some of the offsets are not what I expect. So we have the dummy variable there. So maybe that is what the cause is. So this is pulling from a stack pointer. So ours is S4 versus the target, which is S0. Not a huge deal. Here's where the huge deal exists. So 2E2216A that is the wrong order. These are all getting set, I see. These are all getting set, and what it looks like is basically just everything's getting set to 80 or 128, hex 80, 128. So that ordering works better. Obviously a huge set of these. So these are the corners or the color at each corner. And so this is just setting it to that mid gray. 8F being, no, FF would be white. So 128, yeah. So that's the right in the middle gray. So now we just have the register differences, which is okay. We still have this extra load, however. So let's look at this. When last is being assigned, it's being assigned the value in A0. A0 is offset 38. For us, it's offset 40. This is kind of a gross idea, but it's something. Okay, so I'm going to back that out. That was too gross. All right, so we're storing the value of V0. V0 is S4. And what it looks like to me is we're actually... okay, so I think this is a bug. Because we're assigning next pointer back to itself. So now we have an infinite loop. We'll have to try to get to that code eventually. And as usual with this function, as we get closer on the PSP side, we get further away on the PlayStation side. Not a fun function. 197 is our next function. So our next difference. I'm going to take a look at M2C's version. So M2C couldn't figure out that this was a primitive. That's not helping much. So here's our first major difference. So in this first case, we have x0. X0 looks like it's just whatever the primitive x0 was minus 128, and that's what we see. The next one, however, is a little different. So our S0 register is the target's S5, which is fine. This may be... I see. So X0 and X1 are being done together. And then offset 24 is... I don't remember. I should have this like printed on my... posted to my monitor. Offset 24 is U2. U2 is one of the texture coordinates. So what's missing is a store back to the stack for us, or for the target. We don't have that. It's being used, a register variable is being used. I guess I'm going to create U and O registers, or sorry, U and V registers. These are the equivalent of X and Y for texture coordinates. And assign those as well. The U2 is a little odd. It looks like it's this same subtraction that's going on. Slow compiler. All right. Oh, I'm dumb. Always dumb. We have to offset everything by 4. So it's actually X2 and not U2. Which makes more sense. Pardon the mess. Going really slow. I think it's just decomp.me. Thanks, Orcam. All right, so it looks like, yeah, there's x2 and x3 variables that aren't getting pulled. And my guess is that there is the same for the y variables. What's nice about MetroWorks is if this were GCC, these would be removed due to dead code elimination. There is, these should be 32s. Possibly all of these. I'm not sure why. I see. It's just the difference between whether these are on the stack or in registers. So now what needs to be done is we have all these extra variables that didn't exist on the PSP side. Most likely these should be in place in all of these other locations as well. And so I'm going to have to go through and find all of those and replace them. So what I'm going to do before that is mark what register or stack offset each of these is, which will help determine which of these should go where. The X1 and Y0 being put into registers is because those are the only ones that are being used down here, or the ones primarily being used down there. I'm actually a little surprised that this didn't get put down there, and I have the wrong register there. Either it changed or it didn't change. Yeah, these all changed fast. And that's the hard part with relying on registers is you make a small change and they can all be reallocated in ways that you did not anticipate. All right, so now coming down here, what I would expect is several of these which are like in this case it is using register S7. S7 was Y0. Y0 should be 4-6, which is Y3. And then that matches. Likewise, X0 so in V0 we have S8. So yeah, instead of there's no x1 in this. But we're pulling from 4e, which is what there is. It's possible though, just by doing that little bit, that these registers all changed. So I got to go back and look at it again, and yeah, that's what happened. So now x0 is s8. This is going to be a pain. There's probably a handful of better ways to do this. But brute force works as well. All right, so now down here we have S8, and they have 4E. 4E is Y0. And we may be at the same or similar situation. I'm going to make sure that this is being stored to the right place before moving on. It might actually be helpful to have this off screen to keep track of these. Yeah, so that tracks 4, 6, and S7. That may be the better way of doing it. Actually, maybe I'll do that. I'm a thinker. Instead of relying on what ours are, I will rely on what theirs are. So target's 4E. In this case, the target is 4C. All right. So now this should be a little easier. So they're loading 4E. 4E is X0, as expected. And then loading 4.6, and 4.6 was Y0. On the next one down, 4E is X0 again. Or 6 is Y0 again. But where are we storing this? We're storing to offset 18. So this is actually out of order is what the issue is. My guess is it's this one here. No, that's offset E. Where's offset 18? Oh no, sorry, offset E is what I'm. So these are interleaved. Right. For E and so these look like they're the same. So my guess is, I'm just going to make this assumption, is that these are going to be the same going down. And hopefully these... So now our stack offsets are correct for E. Here we have 4, 6. 4, 6 is Y0 though, so that's fine. I would have to go back and look to see if changing the order of those assignments makes a difference. 4C, and this is a subtraction. And that's probably consistent as well. 8 tucks can play. And yeah, this is bumping us up quite a bit. So 4C is X1, and then S8 is Y1, yeah. So 4C and S8, yes. 4A is X2, S7, Y2, yeah. Yeah. S6 and 4, 8, yep, that looks good too. So yeah, now the difference between these does appear to be just limited to whether things are getting pushed to the stack or not. So that's a favorable change. Let's see if the PlayStation likes this one. It's not been happy with this. It did. It liked that a lot. So that's good. Glad to make a little progress finally on the PlayStation side. Alright, coming down to 244. A seemingly innocuous function looks trickier than it should be. What might be going on here? So we're shifting by 5, which is the same as dividing by 64, more or less. Then we're adding 128. My guess is that this might be a divide by 64. And that looks like a pretty good assumption. There is still the add that's missing. I actually based my assumption on the plus 128, thinking that it had to do something with overflow, but apparently that was wrong. Actually, the 64 was wrong too. Our constants are incorrect. 32? Yeah, 32 is the right one. Alright, so then we still have some moves and other things like that that are wrong, but most of the instructions are correct now. Let's take that back over again and see if the PlayStation liked it. It did like that as well. So what is missing? It looks like some sizing on some of these variables is incorrect. And there may still be more. In general, there's more on the stack. It looks like 8 bytes, additional 8 bytes on the stack that we need to get rid of. So how do we get rid of stuff on the stack? Sometimes it's temporary variables. The PSP is the best place to try to figure that out. Sometimes it's when there are things like this that are obviously contiguous in memory based on their offsets D4, D8. or two words that are right next to each other, it's possible that these are structs, and that or one struct, like a .32, where it has an X and a Y field, and so the address is only loaded once, or maybe it's loaded all together. Let's go again top to bottom and just see if there's anything obvious. The things that I look for when trying to figure out sizes and whether or not sizes are correct is on the PSP, are there additional masks? Are there SEH instructions, sign extend half instructions that might be causing it? For addressing, I'm looking for the difference between, are we loading the top of a word and then adding the bottom, or are we calling load word? That might give some hints as to what type of addressing it is. When there's just register differences, that becomes much harder to tell. Yeah, and I'm not seeing a whole lot. Oh, 60 degrees, that's beautiful. Is everybody running around in shorts? I spent most of my growing up time in the northern Midwest, and 60 degrees at this time of year. T-shirts and shorts weather for sure. Okay, so here is the first case where there's a SEH instruction in ours, but not in the other one. So either the variable being assigned is 32 bits and we want a 16-bit variable, or we have 16 bits. Sorry, we have 32 bits and we're putting in a 16-bit variable. So let's see what's happening on line 200. It's this guy here. I'm a little surprised. Oh, no. Drat. It's just the difference between whether this is on the stack or in a register. And same thing here. The opposite values are being put in the register. So let's look at the loads. Oh, those loads look like they're in the right order. 209. We have a shift happening in the wrong order. It looks like the result, or no, this multiplication should be happening later. Let's see. So it looks like the multiplication is specifically happening to this variable first. And it's actually looks like it's implemented as a shift, but we'll see if the multiplication works. Yeah, that looks like that is fine. I don't know if there's any benefit to the multiply by 16 versus a shift by 4, except that it's easier to read, I find. Oh, here's a load high that, oh, that's, I keep thinking that I found it, I've cracked the code, but that's just because it's using the stack instead of a register. Yeah, that really seems to be what is missing, is register versus stack. This is somewhat interesting on 245. This may be happening in 2 steps, though I don't see the same thing here. What is somewhat confusing me is why there would be a second, or why move the S4 register into S5. And then S0 is being used. So these actually might be separate variables, but it's odd that this isn't happening to the X line. So on this Y line, it appears that this is being stored off in a variable first, and then assigned. With the addition happening later. These getting thrown to the stack instead of a local register, but it is going to this S4 register. Like this is just really odd. I will try it here and see if there's any difference in how this. Yeah, I'd expect additional instructions here that aren't necessary. Yeah, that's bizarre to me. All right, let's see how that's doing on the. I don't think anything really has changed. A little worse. I'm gonna revert that. All right, so let's go over to. Oops, I didn't want to fork that. I want to save it. Let's go back over to the PlayStation and see what's going on there and what is missing. I don't necessarily think yet that these are unrelated. This is the same odd addressing as the other function. So instead of loading this address each time, it's loading the address once and then calculating offsets. But the original is loading each one individually. Let's look at, oops. So if we, instead of making this a struct, so in this case I had it as a vec3. If I made it an array, which is going to destroy a bunch of other stuff. Oops, that's not what I wanted. So x is going to be the 0th element. Y is going to be the first element. And Z the second. So does that change addressing? And it doesn't. So it's kind of the same thing with this 80. And I think we know from other contexts maybe that that should be a vec3, not vec3, sorry, a vector from the GTE library. I'm not sure. Let's see if anything else is using it. Yeah, there is other stuff using it. I could try changing this to a array, but I actually know that this is, or have pretty good confidence that it is a vector because it is in it's in the data section, and so we can see how it's initialized, and it takes up 16 bytes, which is 4 32-bit values, which is the same as a GTE vector. All right, so what else can we do? Not making any progress. Let's keep going through here and see if there's anything up. Again, some loads that appear to be cached. So we're going to S2 instead of going back to the original address. So on 115, there's something going on. Oh, wrong way to access the G API. That cleared up a whole bunch. Those are nice to find. An out of order load on 154. So in this case, this unknown 88 field it's being loaded once up here. Oh, there's a store here. And then in ours, it's getting loaded again. But in the original, it's just using the cached value, which should be fine. So why? Why would it do that? $161. A bunch of this is out of order here on 161. So we're loading the primitive. This this value may be getting loaded in a separate variable. But the PSP version matched here, so yeah, I'm not convinced about that. Yeah, just a bunch of out of order stuff that probably has to do with typing in address modes. Yeah, okay. I'm not going to make any more progress on that today. So what is left to do besides these 4 functions? We can go and see how the permuter is doing on one of them. It hasn't really found much. Found the do while trick, which probably isn't what we want. The other piece of it is importing static data. So to import the static data, there's a couple things we can do. So this is all BSS. So we want to look at the US version of the game and go to data and look at the BSS data that hasn't been loaded yet. And then we get to see some of the shape of how M2C thinks that this data is being accessed. And so things like 63C, which we have down here. So during decompilation, that looked like a primitive. But it probably actually is a primitive, sorry, it looks like a primitive pointer. But M2C's has decided that nothing else is using the value immediately after it. So it treats it kind of as an array of 2 values, but it doesn't look like an array. So what I would normally do here is add a new static primitive pointer with that name. And then I have to go to the splat config. And where SPSS is, it needs to shift down by 4 bytes. I'm actually going to add a static pad. Static pad just says, here's 4 bytes that are not being used, but we need that space reserved. And then I kind of work down and do the same thing. Where is 8644? Do we know where that's being used yet? For all intents and purposes, it looks like a sine 32. That's probably a PlayStation fixed point value. And then add that as well. And eventually, as I'm getting through this, what I'd like to do is, these are just declared at the top of this file, get them closer to the functions that they're that are referencing them. Optimally, these are being declared just above the function that they're being used. I've actually been wondering if some of these are declared within the function itself, so that they have private scope. I don't know if that's the case, though. So I'll do a couple of these. And we can look for this one as well. And that was sine 32 as well. And then the sort stats. Sort stats is actually a type that we know. So instead of extern, that becomes static. And so those are all declared now in this file. I don't remember if if this is compiling yet. So then I go to the splat config, and I'm going to update the offset here to 54, because that is the next variable that hasn't been declared yet. Actually, sort stats unknown8 is part of that same structure, so it has to be 58. And I should be able to extract and make, and I crossed all my I's and dotted all my T's. It should build. Oh, here comes the PSP C file that is in my way. So I just have to get rid of that file. That was from earlier in the stream where I was exporting the PSP assembly. And yeah, that compiled fine. So now we have a little bit more of the SPSS data. There's going to be a new data file here called 8658, which is the offset that it's now at. And this is the remaining data that needs to be included. The last field referenced here is actually just this, I believe it's this 6D4 variable. Let me double check that. I'm sorry, this B88 variable, of course. And we can see if that one exists anywhere. Everything after that, assuming that this is a sine 32, which is how it's being referenced, everything after that is actually just junk. And the make file, we only need to declare up to that value. And as part of the build process, these all get padded to 1,000 bytes, because that is the size of the familiar overlay, and familiar code and data and all that other stuff can't be bigger than that. And because I want to know, 8,000 bytes is 40K. So familiar gets 40K worth of space for all of its code and data. And that is its overlay size and memory. All right, so I think that's where things are going to wrap up today. We've been decompiling Castlevania Symphony of the Night. My browser is not loading nice graphs. Yeah, 40K. I'd prefer 64K. How could you need more? Our familiar, though, we'll give him 2/3 of that. If you want to know more about the Castlevania Symphony of the Night decompilation project, contribute, do other things like that, go to soten.z.dev. I'm just a contributor on the project. This is run by people who have done a lot more than I've done on this project. And you can contribute too if you'd like to. You can find a link to GitHub, you can find a link to Discord. And if you're interested in decompilation, hop by any of those places and see what's going on. If you just like Castlevania, hop on the Discord. And if you want to know more, feel free to chat, like, subscribe, follow, honk, woof, do all the things. And I'll try to get to anything. Always appreciate everybody who shows up in chat. Entropy Gravity Well, Tux and Play, Orcam, Dig Down Deep, Dragon X24. You guys are tirelessly watching every day, and I really appreciate it. I'll see you all tomorrow. Adios.